Okay. Now we are calculating an angle based on two side lengths, okay? So again, you always have to work with the angle they identify. So this is the angle we're looking for. We're looking for theta. And based on that theta, we have our hypotenuse and we have our adjacent. So the trig ratio that uses adjacent and hypotenuse is cosine. So cosine of theta is equal to adjacent over hypotenuse. So cosine of theta is equal to adjacent is 11, hypotenuse is 15. We actually just want to do the division here because we need the decimal to be able to take our cos of that decimal, okay? So I'm going to go 11 divided by 15 gives me 0.73333. 0.7333 repeated, okay? So this is when I have my decimal. So on my calculator, I'm going to go second function, cos, and now I'm going to use my answer button, or you can type in the 7.3333. If you have a graphing calculator, the way you use your answer button is you just hit second again, and you hit the answer or the negative button, which is right next to the equal sign. So I got 42 degrees, rounded to 43. So angle theta is equal to 43 degrees. Did anyone else get that? Yeah? Okay. So you're going to go 11 divided by 15. Okay, and you'll get a decimal. Then you're going to go second function, cos, then second function, answer, and it'll give you 80 degrees. Okay? Because it's the inverse of the function. Okay, next. Based on this angle given, we have our opposite side and our adjacent. Opposite and adjacent is tan, TOA, okay? So tan of theta is equal to the opposite over adjacent. Tan of theta is equal to 11.2 divided by 5.6. So tan of theta is equal to, I'm going to get my decimal here, 11.2 divided by 5.6, and I get 2. Now I'm going to do second function, tan 2 equals, angle theta is equal to 63 degrees. Remember, when you have the decimal and you need the angle, you always have to do the second function of that trig ratio, okay? The second function of that trig ratio. Sounds good? Am I going too fast? Am I going too slow? I actually don't know that I could go any faster, so I think I'm at my max. All right. Okay. Draw and label a diagram for the following angle, then solve the triangle, okay? So basically they're giving you all the information. They're saying the triangle is labeled LMN. Angle L is 90 degrees, side L is 4.5, and N is 3.4. So, first things first, I'm going to draw it to look like a 90-degree triangle because I know that angle L is a 90 degree. Okay? I also know that side length L is 4.5, or maybe right, 4.5, that would be great. 4.5. And N, so I'm going to go L, M, N. Okay? I'm just going around in a circle around my triangle. So angle or side length N is across from that is 3.4. Remember, you have an angle and it always opens to that side. So if this is angle N, then this is side N because that angle opens to its own side. Okay? And that's all I have, right? Do I have anything else? Nope, nothing else. So first things first, what type of triangle? Can I use Pythagorean theorem to figure out the other side length? Okay, so I'm going to say, well, I'm going to label this C, I'm going to label this A, and this B. So I can remember to do C squared minus A squared equals B squared. Okay? So 4.5 squared minus 3.4 squared equals b squared. So I got 8.69. I'm going to take the square root of both sides. B is going to be equal to 2 point, I'm going to keep one decimal place because that's what they did here, okay? So 2.9. And do we know, yeah, sorry, meters. Meters. So when it says solve for the triangle, that means they want everything. So we now know, based on what we know, we now know that that side length is 2.9. We have one of the angles, we know it's 90, but we need another angle. Does everyone agree with that? So you get to pick any angle you want. Just for the heck of it, I'm going to pick this angle right here. And based on that angle, I'm not going to use the side length I just found because I could have made a mistake, right? I could have done a silly math error and made a mistake. So I'm going to use the two side lengths that were given in the question. So I'm going to use, actually I'm going to do this in red. So based on this angle, I'm going to use hypotenuse and adjacent. Is everyone okay with that? I'm going to use hypotenuse and adjacent because those are the two side lengths they give me. So hypotenuse and adjacent, cosine is my angle, my ratio for that. So angle cosine theta is equal to adjacent, which is 3.4, over hypotenuse, which is 4.5. Again, I need to figure out my angle here, or my decimal, excuse me. So I get 3.4 divided by 4.5. And I get 0.75555 repeated. But I want the angle. I don't want the decimal. So I'm going to hit second function, cos, and then I'm going to use my answer button, or I can type in 0.75555, and I got 41 degrees. Angle theta is equal to 41 degrees. Does everyone agree with that? So now I have all three side lengths, and I have two angles. What do all the angles in a triangle add to? 180. So I'm going to call this alpha here. Okay, and I'm going to calculate angle alpha as 180 degrees, subtract my 90 degrees, subtract my 41 degrees. Okay, because I know all the angles in a triangle add to 180. So 180, subtract 90, subtract 41, so I get my last angle to be 49 degrees. And I have now solved the triangle. I'm done. I have all three side lengths. I have all three angles. I'm finished. How was that? Good, bad, confusing, not sure if you'll remember how to do it without me?
Period 2 is over.
Okay, you're on break. What's up, 40? Okay, so a radial mast is supported by a guide wire that is 245 meters in length and that has an angle of elevation. So angle of elevation means if I'm standing here and I'm looking up at something, that's my angle of elevation. If I was standing up on this table looking down, that would be my angle of depression, okay? So 54 degrees. How far up the mast does the wire reach to the nearest tenth of a meter? So really, all we want to know is we want to know this side here, because we want to know how far up that mast the wire's reaching. So it's a right angle triangle. I have an angle, I have a side, I need another side. It's SOHCAHTOA right away. Okay? So based on this angle, I'm going to identify this as hypotenuse because it's approximately 90 degrees, and its x value as opposite. So cosine, or sine, excuse me, sine equals opposite over hypotenuse. Sine, theta in this case is 54 degrees. My opposite is x, I don't know, and my hypotenuse is 245. Again, I'm going to drop a 1 in the denominator of my sine 54 so that I can do Zorro. So I start on my x, draw my z, my first two numbers multiply, then divide by the third. So in this case, I'm going to go, now everyone look up for a second. Okay, if you go sine 54 times 245 in your calculator, you will get the wrong answer. What actually happens is it takes the 54 and times it by the 245, and then it takes the sine of it, okay? So what you need to do is actually put the number first and then the sign of 54 so that your calculator does it appropriately, okay? Or you need to close the bracket and put in another multiplication sign, whatever. But if you put the multiplying number in front, it works every single time, okay? So in this case, I have 245 times sine 54. Oh, I did sine 4. And I get 198. How many decimal places do they want? They want, okay, 1 decimal place. So x equals 198.2 meters. This is a word problem, so you're going to have a statement. Therefore, the guy wire reaches 198.2 meters onto the support mat. Period. Your sentence can be whatever you want as long as you're giving me the solution and what the solution actually means. All right? Give me a second. I'm just going to stop recording.